1.8 pounds. That is how much the American AN/PRC-6 military radio weighed. The closest Soviet equivalent weighed 9.5 pounds and required 2 soldiers to carry it effectively in the field. Both devices did the same thing. When the Soviet engineer assigned to analyze the captured American radio first held it in his hands in a laboratory outside Moscow in the winter of 1951, he did not say anything for a long time. Then he put it on the scale. Then he picked up the Soviet unit next to it. Then he put that on the scale. He wrote the numbers down in his notebook and underlined them twice. The report he filed the following week landed on the desk of the GRU, Soviet Military Intelligence, and made its way up the chain until it reached people who did not want to hear what it said. We're going to tell you everything about what was in that report today, but I have to warn you that some of what follows is hard to sit with. Now, if you're still here, let's start with what was actually in those files, and then we'll get into what it means. This was not supposed to reach the public. The assessment of the technology gap between the United States and the Soviet Union in military electronics was one of the most sensitive classified subjects inside Soviet high command throughout the 1950s. The Politburo received sanitized versions. The generals received versions that were alarming but manageable. The engineers who actually did the analysis knew what it meant, and they were not allowed to talk about it, and some of them carried that knowledge for the rest of their lives. Here is what the report actually said. By the time the Korean War began in June of 1950, the United States military had been deploying miniaturized radio communications equipment for nearly a decade. The SCR-536, developed by Motorola in 1940, was the first true handheld military transceiver. It weighed 5 pounds, fit in a soldier's hand, and allowed infantry units to communicate at a range of roughly a mile without a separate power source or operator. American soldiers called it the handy-talkie. They carried it the way they carried a canteen. It was standard equipment. The Soviet military did not have anything like it. Soviet field communications in 1950 relied on radios that required backpacks, separate battery units, and trained operators who sometimes needed specific technical knowledge to keep the equipment functioning in cold weather. The equipment worked. It was not comparable. There is a number that puts this in context. During World War II, the United States invested approximately $3 billion in the development and production of military electronics, a figure that, adjusted for inflation, exceeds $30 billion today. That investment went into radar, into communications equipment, into the guidance systems for bombs, into the navigation instruments that brought bombers home across the Atlantic. Every dollar of it went through American private industry. Companies like Motorola, RCA, General Electric, Bell Labs, that were already decades into the business of making small things work reliably at scale. The war accelerated an existing industrial trajectory. It did not create it. The Soviet Union had a different trajectory. Soviet industrialization in the 1930s had been focused on steel, on coal, on heavy manufacturing. The Soviet defense industry was exceptional at armor, at artillery, at aircraft. It had the weight-class production capacity that the Eastern Front demanded. What it had not built, at the same depth, was the precision electronics infrastructure that commercial radio and telephone development had created in the United States. There was no Soviet Motorola. There was no Soviet Bell Labs, where, in 1947, 3 American engineers would invent the transistor and change the basic physics of electronic communication forever. The difference was not a matter of effort. Soviet engineers were skilled. Soviet military production was enormous. The Red Army had fought the largest land war in human history on the Eastern Front and won it, in part, through logistics and production capacity that had impressed the Germans and surprised the Americans. The problem was not willingness or manpower. The problem was vacuum tubes. Every radio in 1950, American, Soviet, British, ran on vacuum tubes. The tube was the fundamental component of electronic signal processing. It amplified, it oscillated, it switched. Without the tube, there was no radio. The question was not whether you used tubes. The question was how small you could make them, how reliably you could manufacture them at scale, and how precisely you could engineer the circuits around them. American industry had been refining that process since the mid-1930s, first for commercial radio, and then, with the full weight of wartime production contracts behind it for military applications. By 1950, American tube manufacturing was producing components that Soviet engineers, when they finally examined them, recognized as being 1 or 2 generations ahead of anything they were making at home. The weight difference was not an accident. It was the cumulative result of 15 years of industrial precision that the Soviet system had not yet matched. In October of 1950, as the Korean War entered its second brutal phase and Chinese forces crossed the Yalu River into North Korea, Soviet military advisors were operating at various levels of the North Korean command structure. The Soviets were not officially in the war. Officially, Soviet pilots flying MiG-15s over the Yalu River were North Korean pilots. Officially, the Soviet generals advising on artillery placement were not there. The Americans knew. The Soviets knew the Americans knew. It was one of the quiet understandings of the early Cold War. Both sides could maintain the fiction if it served them. Soviet advisors in Korea were present at command levels that allowed them to examine captured American materiel as a routine part of their work. Weapons were cataloged, vehicles were photographed, medical supplies were assessed, and communications equipment, the field radios, the telephone wire, the signal devices of every category, was collected and documented. Because the Soviets understood, from hard experience in their own war, that communications equipment tells you more about an army than almost anything else. It tells you how that army talks to itself. It tells you how far apart its units can operate and still coordinate. It tells you how fast it can react, how much it trusts its technology, how much it has invested in the infrastructure of command. A radio is not just a radio. It is a statement about what an army believes it can do. What the Soviets in Korea could not avoid was contact with American equipment, specifically the equipment captured from American units in the chaos of the fall offensive. A GRU colonel, named in internal records only by his rank and department, the full file remained classified into the 1990s, received a package in Pyongyang in late November of 1950. Inside was an AN/PRC-6 radio captured from an American unit. The colonel had been briefed on American communications equipment in general terms. He had not held one before. He turned it over in his hands. He pressed the transmit button. He lifted the antenna. He looked at the weight stenciled on the casing and then looked at the field radio sitting in the corner of the room. He wrote 3 words in his field notebook: "Send this home." The radio was packed, documented, and transported through the logistics chain back to the Soviet Union, where it arrived at a research facility outside Moscow in January of 1951. If you're still watching this, hit the like button right now. It helps us keep making videos like this one. The engineer assigned to the analysis, his name appears in a 1992 Russian military history journal as Leonid V, with no surname, consistent with the document controls still in place, later described the examination process in an interview he gave shortly before his death. He said the team unpacked the radio on a clean table and took photographs before touching anything. Then they began disassembling it, component by component, logging each part. The photographs from this analysis were still marked restricted in the 1980s, but the written summary circulated more widely within the Soviet defense establishment. What they found when they opened the casing was not one surprising thing. It was a series of surprising things, each one pointing to the same underlying conclusion. The tubes inside the American radio were smaller than the Soviet engineering team had seen in production equipment. Not by a small margin, by enough that the first assumption was that these were prototype components, not mass-produced ones. It took additional analysis to confirm that the Americans were producing tubes of this specification at scale, that what they were holding was not an experimental device, but standard-issue field equipment. Every American soldier who wanted one had one. The circuit layout was denser than anything the Soviet team was manufacturing. The tolerances, the precision of the measurements involved, required manufacturing equipment that the Soviet facilities did not have. The team filed a supplementary report requesting a list of the machine tools that would be necessary to replicate the production process. The list was long. Several of the items on it were not available in the Soviet Union and would need to be acquired, through purchase or through other means. The battery design was efficient in a way that required materials processing the Soviets had not achieved. The antenna was a specific alloy. The housing was a specific grade of polymer. Every component, examined individually, pointed to the same thing. This was not one piece of technology that could be copied in isolation. It was the product of an industrial ecosystem. To copy the radio, you did not just need the radio. You needed the factories, the tooling, the material science, the manufacturing precision, and the quality control infrastructure that had produced it. You needed, in short, a different version of your own industrial base. There was also this. The American radio worked in temperatures that Soviet field radios sometimes did not. The Korean winter in 1950 was one of the coldest on record. Temperatures at the Chosin Reservoir dropped to minus 35 degrees Fahrenheit. Equipment that had been tested in milder conditions broke. American field radios, designed and tested for extreme cold as part of the standard development process, kept functioning. Soviet standard equipment had known cold weather vulnerabilities that required additional procedures to manage. The engineers noted this in the analysis. A radio that works at minus 35 degrees without a special procedure is a different kind of weapon than one that does not. The report that went up the chain in the spring of 1951 used careful language, because the man who wrote it understood that what he was saying had implications beyond the radio. He wrote that Soviet military electronics were operating at a disadvantage that could not be corrected by a single development program or a single acquisition. He wrote that the gap was systemic. He noted, carefully, that this assessment applied specifically to the miniaturization of field communications equipment, and that other areas of Soviet military technology remained competitive. He hedged where he could. But the conclusion was in the numbers, and the numbers were underlined. The report reached the level of the Soviet Defense Ministry. It also reached the GRU, which took from it a specific operational priority: acquire American electronics technology by any means available. This was not a new mission. Soviet intelligence had been running technology acquisition operations since the 1930s. What changed after 1951 was the specificity of the targeting. The Americans were ahead in miniaturized electronics. The Soviets needed to know exactly how far ahead, and they needed to close the gap, and if they could not close it through their own engineering fast enough, they would close it by getting inside the American engineering process. Alongside the engineering programs, the Soviet intelligence apparatus shifted its targeting in a way that took American counterintelligence several years to fully map. The GRU and the KGB ran parallel operations, sometimes coordinating, sometimes competing, against the American defense electronics industry. The targets were not the device designs themselves, which could be copied imperfectly at best. The targets were the process documents, the manufacturing specifications, the machine tool calibration records, the quality control procedures that described how American factories maintained the tolerances that made the equipment possible. The Soviets understood, from the 1951 analysis, that the radio in front of them was not the problem. The factory that made it was the problem. And the factory could not be captured. It could only be understood. The operational details of what followed are still partially classified. What is known? Through the 1950s, Soviet intelligence ran networks targeting American defense contractors with electronics divisions. Several of those networks produced technical documents. Some of those documents described production processes. Whether any of them materially accelerated Soviet electronics development is a question the historians still argue about. The engineers who worked the problem said the fundamental issue was not information, it was tooling. You could have all the blueprints in the world and still not be able to manufacture the component if your machine tools were not precise enough. The Soviets solved that problem, eventually, though not on the timeline anyone in the 1951 analysis had hoped for. The transistor created a new layer of complexity. American industry, with Bell Labs at the center of it, moved into transistor-based electronics through the mid-1950s faster than anyone had predicted. The Soviet Union produced its first functional transistor in 1953, not far behind the Americans on the basic science. But producing a transistor in a laboratory and manufacturing it reliably at scale in a military application were two entirely different problems. The precision manufacturing gap that the 1951 analysis had identified in vacuum tube production applied, with equal or greater force, to transistors. The components were smaller. The tolerances were tighter. The machinery required was more specialized. Soviet defense electronics programs that had counted on transistor technology to close the gap found that the gap in transistor production was, in some respects, larger than the gap in tube production had been. The Soviets solved that problem eventually. It took most of a decade. By the early 1960s, Soviet military electronics had closed a significant portion of the gap. By the time the transistor replaced the vacuum tube as the dominant technology, a transition the Americans made faster and the Soviets followed, both sides were operating in roughly the same generation of technology, though the Americans retained an edge in miniaturization into the 1970s. The 1951 analysis report was formally reviewed by a Soviet Defense Ministry committee in the spring of 1952. The committee included engineers, intelligence officers, and at least one general. According to the summary that was later partially declassified, the committee agreed with the analysis, authorized the supplementary equipment acquisition list, and recommended an accelerated development program for Soviet military field communications. The program was approved. The funding was allocated. The engineers went back to work. The committee did not put in the formal record, but what several participants described in later interviews was the room at the moment when the weight comparison was presented. The number 1.8 pounds on one side, the number 9.5 pounds on the other, both radios doing the same job. A general in that room reportedly said nothing for almost a minute. Then he asked how long this had been the case. No one in the room had a comfortable answer. The GRU colonel who sent the radio home from Pyongyang retired in 1963. His name is not in the public record. The engineer who analyzed it, Leonid V., died in 1994. In the interview he gave near the end of his life, he was asked what he remembered most clearly about the day they opened the casing and started taking it apart. He said he remembered the smell of the components, the particular smell of American manufacturing, which he said was different from Soviet manufacturing in a way he could not describe technically, but recognized immediately. He said that smell stayed with him. He knew, from the smell, before the measurements confirmed it, that this was something they had not seen before. He said, "We put it on the table and we knew we had a problem. We did not say it to each other, but we knew." They remember the smell of the American components, the specific industrial smell that was different from the smell of Soviet manufacturing, and that told them, before any measurement confirmed it, that they were looking at something from a different kind of place. They remember the weight in the hand when they lifted it. 1.8 pounds, light in a way that did not feel like a compromise, but like a decision someone had made very deliberately. They remember writing the numbers down and looking at what they had written and understanding that the numbers would require a response, and that the response would take years, and that the years would not be comfortable ones. There is a particular quality to the kind of knowledge these men carried. It was not the knowledge of a battle they had fought or a decision they had made. It was the knowledge of a gap, a measurable, documented, technically specific gap between what they had and what someone else had. That knowledge could not be unfiled. It could not be reclassified out of the minds of the people who had produced it. The men who did the analysis in 1951 knew, for the rest of their working lives, exactly what they had found on that table. They knew the weight. They knew the tube dimensions. They knew the number of years the Americans were ahead at the moment of the examination, and they tracked, as they aged, whether that number was getting smaller or larger. Some of them saw the gap close. Some of them worked their entire professional lives on the problem and never fully resolved it. The men who filed those reports in 1951 lived with the knowledge for the rest of their careers. Some of them saw the gap close. Some of them worked their entire professional lives on the problem and never fully resolved it. They did not talk about it publicly because the classification did not permit it, and by the time the classification lifted, there was not much of a public left to tell. The file was declassified in fragments, across multiple years, in archives that are still not fully open. What exists is enough to reconstruct the outline. A radio that weighed 1.8 pounds, an engineer who underlined two numbers, a report that said the word systemic and meant it. Now you know what was in the file. Did your family live through the Cold War on either side of it? Tell us in the comments below, and if you want more stories like this, the ones that were never supposed to reach you, subscribe and hit the notification bell so you don't miss what's coming next. Thank you for watching.